Hi there, I'm Mrs McTaggart, and in this video we're going to look at some trigonometry questions. These are the big mark exam questions that appear probably at the end of your paper too. And I've nicknamed them the double sine rule questions. Now you can do these questions using sine rule and SOHCAHTOA, but after years of marking I've thought very few people are doing SOHCAHTOA, and the people who do SOHCAHTOA are the ones that mess up. So I've started teaching it and calling it double sine rule because it's so easy to identify by the basis of the two diagrams they use every year. So I will show you the two different style questions. Okay, so my two examples have come from old past papers. I've just taken out a load of the story around about it. So this first question here is talking about, we've got a helicopter H that's hovering between the two buildings A and B on the bottom here. And the two buildings are 1,500 metres apart. They want us to find the height of this helicopter. Now, the height of the helicopter, I am going to illustrate by putting in a dotted line, which is not there. Now, the dotted line would definitely help, I think, if it was there. Sometimes it is, sometimes it doesn't. Now, we have to assume that the ground is flat, horizontal, so that this line from the helicopter to the ground is meeting at right angles. Okay? So we've created two right angle triangles. But having a quick look at this, there is no way to find this dotted line in one go. If you were to cover up and look at the left-hand triangle, you need this side here to be able to then get H. Similarly, if you wanted to look at the right-hand triangle, you would need this side here in order to get H. So what we have here is a dilemma. You have to choose which of these sides you can go calculate, because we can't actually find them. If you just focus on the big, giant triangle, if I take my dotted line back out for a second, if you just focus on that triangle, we can work out that the angle up the top here, if you take these both away from 180, is 75. Okay, and if we focus on this big triangle here, we have enough not to use cosine rule, but sine rule. Sine rule needs us to be able to do the x factor. So if I wanted to call this angle x, I have enough to go perform sine rule just now and do that side over that angle and then that side over that angle. And then this would get me the left-hand side. Then I can come back and put that dotted line in and use my right angle triangle. Now, similarly, as I said, you could also go find this one over here on the right-hand side. But I did a little survey with my class and most of them chose the left-hand side. And that's kind of where I go as well. It's always fun to mark because there's two possible routes round to get this question. So I'm going to go find x using sine rule. So it will be, using our sine rule, it will be our unknown, x, over the opposite angle, so over sine 55. If you need to, you write out your sine rule, you tick off all your angles A, B and H, you tick off the side which is little b and little h, and you'll be using the b's and h's. But if you have done loads of practice of sine rule, you probably are at the stage that you can just go straight to this bit. So unknown over sine 55 equals the side we do know, which is 1,500 over sine 75. Now, just to point out, one thing you cannot ever do in this question is draw a dotted line down the middle and half the 1,500. There is nothing in here to tell you this is isosceles or symmetrical or split down the middle. All right? Never ever assume. So this is what we're doing. We're doing sine rule on the big outer triangle. At this stage, to get x on its own, I just need to move that sine 55 to the other side and make it a multiplication. So I have x equals 1,500 times sine 55 all over sine 75. And this will give me an answer of 1,272.07. Now you can keep this exact on your calculator, or you can round it to 2 decimal places. I'm keeping it exact just because that's what I do. I like using the answer button. Right, what I'm going to do next is I'm going to redraw that right angled triangle if I was to split this down the middle. So if I, oops-a-daisy, redraw this, and I was working on the left-hand side, so I'm going to draw the left-hand side triangle. This is 50. This is my h that I'm going to find out my height. We've just worked out that this is 1272.07. And we also know that this angle up here would be 40. using angles in a triangle adding to 180. Don't really think I need that one though. So sine rule again, you could use SOHCAHTOA as I said, but double sine rule is the best way to go here. So we're going to have our unknown over sine 50. So h over sine 50 equals the side we know over sine 90. So 1272.07 all over sine 90. Then we need to move that sine 50 up to isolate the h. So you've got 1272.07 times sine 50 all over sine 90. And I have used the exact answer, so I've just used my answer button times sine 50 and then divided it, and I got 974.46 metres. Okay. And that's that one. That's what you would have got. Now, a little thing to point out to you, if you ever wonder, sine 90, if you type it into your calculator, is just 1. So what you're actually doing is just the top line, and then when you're dividing by 1, it doesn't change your answer at all. Because SOHCAHTOA would have just had you doing your hypotenuse times sine of your angle. Your hypotenuse is the 1200, your sine your angle is sine 50. So that is our final answer to that one. And if they don't ask you for rounding, it's up to you, 1 or 2 decimal places. I like to just do 2. Alright, so this is a common one. It's quite often talking about a helicopter or the height. I've seen one, a height of a hot air balloon. They can sometimes give you the exact same triangle but drawn upside down, and it's basically, it's always finding the vertical height of something using a triangle on the ground. The second scenario is this one here, and this is the scenario that came into the 2022 exam. This one's a bit more obvious as a double sine rule, and they quite often use this one, but they can reposition it. So sometimes you can see it positioned like this, sometimes you can see it like that. So just be aware, if you see this shape here, then it is your double sine rule question. So I'm just going to move this up here out of the way. First thing I would do in this question is work out all these blooming missing angles. So let's work out the missing angles first of all. So opposite this 57 on a straight line with 57 would be, I've gone blank, 123. Up the top here in the right angle triangle with the 57 and 90, that makes 147. So this one up here would be 33. And the last missing angle to get is that wee skinny one up the top. So your 32 add your 123 is 155. Take that away from 180, it makes this wee one up here 25. So in this one, that is your starting point, is to fill in all your angles. Okay, so again, the problem with this one is you have 2 ways to go. So to get this height T to be, I need to know another side in either this right angle triangle, so namely I need to know this side here, or if I was looking at the giant right angle triangle, I could just look at the full thing, and if I knew this side here, I'd have enough on this one. Now in my previous example, I said, I always like to find the one on the left. On these ones, for some reason, I don't like the skinny triangle. I like to try and find, use the one with the right angle triangle on the right, if that makes sense. So I'm just going to rub out these lines that I've put in. And we are going to basically, our method will be, is we are going to find this line here by using this skinny triangle. So I'm going to use that triangle first. And then once I know X, I'm going to use the right angled triangle on the right to get my height. Okay, let's have a look. So it's up to you. You could draw this out again, or we're just going to focus on the HGT triangle. So to get X, it will be X over my unknown X over angle 32. So X over sine 32 equals the side you know, which is 46, over the opposite angle, which is the wee skinny one up the top, which is sine 25. I need to move the sine 32 up, so 46 times sine 32 all over sine 25 And if you type that in, you will get an answer of 205.399. Oh, I was going to keep it as 399 for now. In fact, no, let's just round it 2 decimal places, 205.40. Okay, so I'm just going to quickly redraw the second triangle that I'm using. So I'm now using this triangle here. This is 57. This is the height I want. And I now know that this is 205.4. So using sine rule again, it will be my unknown over sine 57. And then it will be the answer I've just worked out. So 205.4 all over sine 90. Cross multiply, move up your sine 57. So we've got 205.4 times sine 57. You will fit in all over sine 90. And I'm going to just use the exact answer because it's still sitting on my calculator screen. And I am going to times that by sine 57. Dividing it by sine 90 makes it 172.26 to 2 decimal places. Okay, so they can ask different bits within that triangle. Sometimes they might ask you for this wee bit down here instead. It would just be doing a different part of sine rule on the right angle triangle. So that's the way I would do it. I hope this has helped. These are tricky. They're really, really tricky. But if you recognise it's double sine rule, there's a lot of easy marks to get within this question. And I've pulled a couple more just to keep showing you the same diagram. You could pause and try these. This is the one from the 2022 exam, and it was a wee bit different on this one. They actually wanted the width of the river, but it was the same thing. I would have filled in all my angles. I would have got this one first of all, and then used the right angle triangle on that one. So in this one, you're using the skinny, wonky looking triangle first to get X, then the right angle triangle to get Y. Same diagram, just drawn the other way around. In fact, is that the one I just used? It might be. This one here, same diagram, facing the other way, looking for height of building. This one goes back to my first example, where you have to split it down the middle. So split it down the middle, use the whole triangle to get X, then split it down the middle, use the left-hand side to get Y. And same diagram as previously, but it's upside down. This time they're giving you the dotted line. Again, I would probably use the full triangle to get the left-hand side, get X, use the right angle triangle to then get Y. So I would use in the left-hand side for that one. So hopefully you see them and recognise these questions all look really, really similar. This is again the same as my first example, turned upside down. Use the full triangle, maybe get this slope X first of all, and then use, you can actually use this right angle triangle for this one, or you could use that one there to then get your H, but H would just be in that kind of position instead. Anyway, I hope this has helped. These are difficult questions. They're big 5 markers, but the difficulty is in recognising that's a double sine rule. Okay, thanks for watching.